a couple of different ways that the results go into WATCH, and this is the part of the whole process in WATCH in general. Is it brings hydrologic models together with climate modelers, and the whole purpose is to improve models on both sides, to do the comparison. And the original purpose was to improve the hydrologic representation within the land surface models of the climate models. Well, some of our work is to do the same thing, but we're incorporating additional modelers to the system. So we have population modeling, we have energy modeling, we have land use modeling, and all these modeling techniques improve the information that's available to the climate models. And so it improves the climate models in a number of different ways. One, it improves them methodologically. Then they see, well, this is how demographers do their population projections, and they can include those into their own representations of the world, essentially. But also with population, it's just as easy for them to take existing population projections, our population projections, and feed them into the model as their input data. So this is where their demand is coming from. The other parts of work block 2 were to provide some of these curves, some of the methodologies of how water use changes, maybe with economic development, so how water use changes with income, how water use changes with technology change, how water use changes with different cropping patterns, for instance. So some of these were just to develop the curves which they could use in their models. And so now Kassel, the University of Kassel, has developed several curves for water use over time, over economic development, over technological development, and our group and other groups have also developed, how much water is used during the season for cropping, the cropping season, basically. So you have your crop cycles, and throughout the crop cycles you have different water demands, and those types of functions are then incorporated into the hydrologic models, into the global climate models. And so part of it is just to use the experience from other disciplines to improve these global models. The other part is where it can't be done. In many cases these systems are very, very complex. We're doing agricultural modeling, and not everything that's incorporated in the very specific agricultural modeling can be added to the hydrologic models at this point, or the climate models. It's getting there, and WATCH has improved that situation. But in the meantime, what we can do is we can provide the crop water deficits, which is the amount of water a crop would need to reach its full potential, in addition to what's provided already by precipitation, by rainfall. And so these can give an indication globally of how much water is demanded for agriculture, for instance, and we can project that out into the future in a little bit better way with models that are specifically designed for that purpose than the current hydrologic models or climate models. And so there's a little bit of both. Sometimes the hydrologic and climate modelers are incorporating the modeling methodologies into their models, and sometimes they take our data, our more advanced scenario projections, and use those directly as input, or they use them to verify the processes within their own models, which are somewhat more simplified but may give a fairly good representation of the physics involved.